Finally, we're going to look at the truth tables for biconditional statements. Now remember that biconditional statements, we say that P if and only if Q. Biconditional statement is when both if P then Q and if Q then P occur. Okay, so you have the conditional going both ways. So let's see what happens to a truth table when that's the case. Essentially, we're saying that the biconditional statement is equivalent to a conjunction between if P then Q and if Q then P. Okay, so that's the compound statement that we're going to build a truth table for. And that truth table will be then the definition of the truth table for the biconditional statement. Okay, so we're looking for, we've got P and Q to start off, and it don't matter if there's a line between them. And so P is true, true, false, false. Q is true, false, true, false. All right, and so now what do I need? I need if P then Q. And I need if Q then P. And I need the conjunction of those two compound statements, those two conditionals. So it's if P then Q and if Q then P. All right, so going through this left to right, if P then Q, remember the conditional is false only when the antecedent is true and the consequent is false. So we would need true, false in order to get a false here, and everything else will be true. So that occurs in the second row, true then false. So that one's false. That's true, true, true. Everything else is true. Okay. Then for this conditional, again, the antecedent must be true, the consequent must be false. So true for Q, false for P, in order for this to be false. So let's go down the Q column. Here's a true, but that's true. So that's not going to be false. Here's a true and false. So here it is. In this third row, we'll have a false because the antecedent is true and the consequent is false. Everything else is true. And then with the conjunction, remember a conjunction is true when both parts are true, okay? False everywhere else. So as long as both of these are true, I have true, true here. I have false, true, so that's false. True, false, that's false. And true, true, so that's true. Okay, so the conjunction has, conjunction is true when both P and Q are true, or when both P and Q are false. Okay, so that's the only time that a biconditional is true. So by definition, a biconditional is true when the component parts by component parts I mean the antecedent and the consequent, but it's really an antecedent and consequent the other way as well. So a biconditional is true when the component parts have have the same truth value. Okay, that means they're either both true or they're both false. All right. If you have a true and a false or a false and a true, you get both false biconditional statements. All right, so yeah, so that gives us an idea of what the truth table will look like then for a biconditional. And then of course we can incorporate biconditionals into bigger statements, maybe including conjunctions and disjunctions and conditionals. So maybe an example, maybe I'll keep that definition up here for a moment. Let's say we had something like not P or Q, biconditional if and only if P implies not Q, or P if P then not Q. I don't know, I'm making something up here. We'll see what happens when we fill out the truth table. I don't know what's going to happen. So I've got P, I've got Q. Let's start this off. P is true, true, false, false. Q is true, false, true, false. You'll probably get sick of writing those two columns because there's a lot of these coming up here in the homework for these few sections that we're looking at. I need not P and I also need not Q to pull this off. So not P, not Q. So not P is going to be false, false, true, true. Not Q is going to be false, true, false, true. Then I look at not P or Q. Remember, this is a disjunction. Yeah. And so disjunctions are false only when both are false, right? As long as one or the other or both are true, that will be true. So I want both to be false in order to make this false. So not P or Q. They're both false in the second row and nowhere else. So that will make this false. But as long as one or the other or both are true, then the disjunction is true. Then I have the conditional. P, or if P then not Q. And with the conditional, remember everything is true except where your antecedent is true and the consequent is false. So if it's true, false, then you get false. Everything else is true. So I need to see true, false. And sometimes it's nice to just write that in there to keep in my mind what's going on. So with the conditional, I need P to be true. That happens twice. And not Q to be false. That happens in the first row. So that one's going to be false, and everything else will be true. So true, true, true. And then, finally, the most dominant connective is the biconditional here. That's outside the parentheses. Because I'm running out a little bit out of room, I'm just going to pretend I inputted everything there. But it's this statement copied over. So what I need is for, again, a biconditional is true when either you've got true, true on each side or false, false on each side. So when I come down these two columns here, columns 1, 2, 3, 4, 5, and 6, I need both true or both false. So here I got one of each, here I've got one of each, here I've got both true, here I've got both true. So at the both trues, we're going to have true, and at the both false, we're going to have, or at one false, we're going to have falses. So it's false, false, true, true. Okay. Yeah. So that should help us out. Basically, what's interesting is that these four end up being exactly the same as not P. You notice that, right? And so something very interesting happens when columns in the truth table are equivalent. We'll talk about that in the next section.